What up, peeps? I'm back. Now, today what we went over in class were multi-step equations. So now the equations are getting more and more difficult, okay? We're done kind of covering the basic equations and multi-step equations for 8th grade. Now we're bumping it up, kind of making it a little bit harder with in terms of the coefficients we use. What I mean by coefficient is the number in front of the x. Now we're going to get decimals. Today we're going to go over the decimal multi-step equations. And then on the future videos, we're going to go over fractions. Fractions with like denominators, which are pretty easy if you understand the decimal ones. And fractions with unlike denominators. So now we're going to solve multi-step equations with rational coefficients. So this is what I mean. In class, you guys got this worksheet. Obviously, if you were absent, you just follow along. What I'm going to do is I'm actually going to write down the problems. Just write them down in your notebook so that you come back the next day, you're up to speed with everybody else. So before we start with our whole discussion with multi-step equations with decimals, we need to go over place value. So the first number, and I'm just making this up, write this down, 5 and 374 thousandths. So we have to go over place value. Place value is very important in terms of decimals. So this 5 is in the ones place, right? You learned this hopefully in elementary school, maybe in 6th grade too. I usually teach it in 6th grade when we're dealing with converting decimals into fractions. This 3 is in the tenths place, okay? Tenths place. Write this down like I said. The 7 is obviously going to be in the hundredths place. Hundredths place. And then we have this 4 is in the thousandths place. Write this down in your notes if you didn't write it down. Okay? Again, when you come back, I'm going to give you this worksheet. The worksheet has everything in here. Okay, so again, you need to understand your place value. So obviously this is on the ones place. Tenths, hundredths, thousandths. I can give you the 10,000ths, 100,000ths, millions. But honestly, for 8th grade, and based on the questions I see on the Smarter Balance, also in your book, the largest place value that we'll ask you is maybe on the hundredths. You occasionally, rarely see the thousands. But I'm throwing some thousands problems in there. So in order for you to do equations with decimals, make sure you know your place values. Okay? So let's go over our first example. So our first example is this. This is how you read it. 4 tenths minus 1 and 2 tenths equals 15 hundredths x plus 8 tenths. There's different ways you could solve this problem. First of all, I'm allow you to use your calculator, because in the Smarter Balance exam, you're able to use your calculator for these type of examples. Okay? So there's different ways you can do it. A lot of you guys right off the bat were like, well, yeah, it's pretty easy. Draw the barrier and box the largest variable. So that's where some of you guys were kind of having trouble with. A lot of you guys said that 15 hundredths is bigger than 4 tenths. And it's pretty obvious because that's a 15 versus that's a 4. And that makes a lot of sense. But remember that this 4 has a big fat 0. So that makes it a 40 hundredths, okay? Which is bigger than this. So eventually we will box this up. Now, there's a better way. Then obviously that's bigger one, so you have to do minus 0.15x, minus 0.15x. You work with all those decimals. The good thing is you have a calculator. You could do that method for sure. But the biggest hint I could give you with this and fractions as well is the first thing you want to do is eliminate the decimals. The decimals are the ones that usually make the problem complicated. Once you eliminate all the decimals first, then you will be able to solve pretty much any decimal multi-step equation problem. So this is what I mean by eliminating the decimal. What I do first is I look at the last digit in every number. The last digit in every number. Okay, so that's the last digit of each number. And then I ask myself, what place value is the last digit? Well, this one is in the tenths place. This 2 is also in the tenths place. And this one right here is in the hundredths place. And that one's also on the tenths place. What you want to do is multiply every single term here by the largest power of 10. The reason why you do that is eventually you're going to make that decimal disappear by moving it to the right. Hopefully you learned it in elementary school, is that if you multiply by a power of 10, your decimal moves one time to the right, okay? So for example, if you multiply this number by 10, then the decimal will move one time to the right, based on the number of zeros that this number has. If you multiply this by 100, the decimal moves twice, because the 100 has two zeros. Okay, so you always want to multiply by the highest power of 10. Okay, so in this case, the highest power of 10 is 100. So I'm going to have to multiply every single one of these terms by 100. Okay, so here we go. Multiply all of these by 100. So I'm going to have to multiply this by 100. Show me you're multiplying by 100. This by 100. Boom. This by 100. And this by 100. Now, some of you guys are like, well, why can't I multiply by 10? You could. But you're going to notice that if I multiply by 10, you're going to get rid of these decimals, but you won't get rid of these decimals. This decimal is just going to jump right here in between the 1 and the 5. You'll eventually get rid of this one. Sorry, this one, this one, this one. If you multiply by 10, you'll get rid of the decimal, but not on this one, okay? You want to eliminate the decimals right off the bat, immediately. So the way you do is multiply by the largest power of 10. Therefore, we're going to multiply by 100. Now, you can use a calculator. I don't mind. So 100 times 0.4. If you use a calculator, you'll be fine and get the answer. But hopefully in elementary school, you remember the shortcut. You just count how many zeros the 100 has, and that tells you how many times you move the decimal. Every time you move the decimal, it's like you're multiplying by a power of 10. So I'm just going to do this right here on the side. A lot of you guys in class, when you see it the first time, eventually, you don't have to do it anymore. So 0.4, move the decimal twice to the right. 1, 2. We have an empty spot right here, so we add a 0. So 100 times 0.4 will become a 40x. Whoa, you just eliminated the decimal. That 0 in the front you could throw out. 100 times 1.2. Let me show you the movement of the decimal. The 100 has two zeros, so I'm going to move it 2 times to the right. 1, 2. I have an empty space, so I put a 0. So 100 times 1.2, whoa, it becomes 120. You just eliminated the decimal. Equals 0.5 times 100. Okay, 0.15, I'm sorry, 0.15. So it has two zeros, move it twice to the right. 1, 2, whoa. This then becomes 15x. Then let's do this one, 100 times 0.8. The 100 has two zeros, so I have to move the decimal twice over here. 1, 2, fill it in. So 0.8 times 100 is 80. And there it is. That's how you pretty much eliminate all the decimals. This becomes like a simple problem that we've been doing so far in class. You just have higher numbers. That's why I'm allowing you to use a calculator in this case. On the quiz or an exam, I'll also let you use a calculator. So it's the same thing, little brother, little sister kind of strategy, because you have two variables on both sides. So I know I draw my barrier, 40 is the biggest one, so I have to bring the 15x over here. So since that one's positive, the opposite of a positive, or the inverse, I'm sorry, is negative 15x. Negative 15x. These cancel, they become 0. 40 minus 15 will become 25x. Now let me ask you this. Before I started, I should have asked you this. 40x, 15x, are you going to get a special answer, a special solution? Are you going to get many solutions or no solution? You won't, because they're not identical twins. If they're not identical twins, then you are going to get one solution. Just be aware of that, because sometimes you could get many solutions or no solution on these problems as well. So let's keep on solving. You didn't touch these, so drop it. So minus 120, drop the equal sign, and drop the 80. Okay? Circle your variable with this coefficient in front. Who do we have to get rid of? We focus here because that's where the bubble is. Who's not inside the bubble? The minus 120. The inverse of negative 120 is positive 120. Positive 120. That cancels out. I don't have any more room. Let me move this thing over here. I'm going to move over here. Sorry. So 25x equals 80 plus 120 will eventually give you your 200. We're almost there. Divide both sides by 25. And what I've noticed, what some of you guys did on your quiz, is you were dividing by a negative. You don't switch the signs. You divide by the same number. Because the opposite of multiplication is division. If you're changing the sign to a negative, you're saying that the opposite of multiplication is subtraction. That doesn't make sense. Okay, so 25 divided by 25 is 1, so you're just left with x. That's what you want. You want to isolate your variable. 200 divided by 25, if you think about quarters, there's 4 quarters in a dollar, so there will be 8. So the answer for this problem, this complicated problem, will equal to 8. Now another thing that one of my students mentioned was, could I just turn all of these into fractions? For sure. You can change all of these decimals into fractions, find the common denominator, and then you could do kind of the same basic procedure. Because that's what we're going to be doing with fractions, literally multiplying every single term. The biggest mistake that I see a lot of students is, yes, they understand they have to multiply by 100, but they only multiply certain numbers. Like, they multiply this, 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 and they forget to multiply it by 100 to this one. That will throw off your problem completely. Let's do another one. So in this case, we have 0, well, technically it's 7/10 minus 4/10, well, 7/10 x equals 3 52/100 minus 28/100 x. Looks complicated, but believe me, it's very easy. First thing is, do I have identical twins? Is this variable equal to this variable? You don't. So you don't have any special answers. Okay? So the next step is, I need to get rid of all the decimals. Decimals make the problem complicated. So what I do in order for you to get rid of the decimal is, I look at the last digit, and then I ask myself, what's the place value of the last digit? Well, this place value is 10. This place value is 10. This place value right here is 100. The 2 is on the hundreds place. This is on the hundreds place. Look at the largest power. Well, I have to multiply by 10 or 100. Well, in this case, what's the largest one? It's 100. So I have to multiply all of these by 100. So, and show me that you multiply by 100. You have to multiply this by 100. You have to multiply this by 100. You have to multiply this by 100. And you also have to multiply this by 100. Okay, so let's go ahead and do that. Okay, so 100 has two zeros, so that means I have to multiply. Let me just do it on the side. That means I have to move the decimal twice. So 1, 2. Ooh, 100 times all of this big junk becomes a 70x. Let's do this one. 0.4, move it twice. 1, 2. That will become minus 40. You see how we're eliminating the decimals? Let's do this one. Move it twice. 1, 2. Oh, the decimal goes all over here, and this becomes 352. Same thing over here. Let me do it on the side. Move the decimal twice. 1, 2. That becomes 28x. And look at that. That has now become into a simple problem. Yes, we have large numbers, but simple. It's an easy process. It's an easy procedure. Okay, draw your barrier. Which one's bigger? Positive 70x or negative 28x? It's going to be the positive 70x. Okay, so that means I have to bring this guy, jump the fence, come over here. So I have to do inverse operation. The inverse of a minus is positive 28x. Positive 28x. Boom. Cancels out. 70 plus 28 is 98x. Drop the minus 40 because you didn't touch it. Drop the 352. Okay? Now what you do next is circle the variable. Same process. Circle the variable, draw the barrier. Focus on the side where your bubble is. Is your bubble on the right or on the left? Well, it's on the left. So what's not inside the bubble? The minus 40. So do the inverse. The inverse of minus 40 is positive 40. Positive 40. That's 98x. Equals, that's 2, 9, 392. Okay, I'm going to move up here because I don't have any more room. So I have 98x, 392. Okay, we have to let x to be by itself since it's multiplication. The opposite is division. No, I'm not switching it to a negative because the opposite of multiplication is not subtraction. You see that? Did you see I almost did the negative? Ah, Hernandez, it's the age. It's the age. I'm going to use my calculator to make this quick. 392 divided by 98. And that will give me x equals 4. And that is my final answer. Now, don't get used to it. Don't think that all the answers are going to be positive. Remember, what happens if this was negative 392? Use the bear. Remember, the bear is always the one that helps you out. So a negative divided by positive, then that would have been negative. But in this case, it's not. But don't get used to that all the answers are going to be positive. Also, don't get used to that all the answers are going to have one solution. Sometimes you get a special case. Now, what I want you to do, if you're following along with the worksheet, turn it over. Let's go over the first one. Okay, because a lot of you guys, based on these two problems, are like, well, I'm always going to multiply by 100. And that's not the case. You're not always going to multiply by 100. Sometimes you have to multiply by 10. And on some of the problems, you're eventually, let me erase this too. Eventually, you're going to multiply by 1,000. And if I give you a challenge problem, you have to multiply by maybe 10,000. Don't worry, I won't do that to you. That's too much. So this one is in the back. It's the first one in the back. 2w minus 0.4 or 4/10 equals 1 plus 1 and 8/10 w. Here we go. So multi-step equation. First thing I do is, am I going to get a special answer? No, I'm not. They're not identical twins. So that means I'm going to have one solution. So first of all, I don't like decimals. Decimals are confusing. You could solve it with the decimals, but I want to get rid of the decimals. So what I do is I always look at the last digit. Last digit. Well, this one only has one digit, same here too. Last digit. The 2 is in what place value? It's in the ones place. That's in the ones place. No, oops, let me put it down here. The 4 is in the tens place. The 1 is in the ones place. And that 8 is on the tens place. What you do is now is, which one has the largest power of 10? Well, is it 1 or 10? Well, hopefully you say it's 10. So you're going to have to multiply all of these terms by 10. So you're going to multiply this by 10, this by 10, this by 10, and this by 10. Make sure you multiply all of them. Again, this was the biggest mistake we saw in class. You guys knew how to do it, but you'll forget to multiply this by 10 and this by 10. Okay, this is what you guys would do. You're like, oh, this is going to be 2w. And then this one is, oh, there's 1 0, so I only have to move the decimal once. You get the decimals right, but when it deals with the whole numbers, it's wrong. For this one, 10 times 2 is 20w. 20w. 10 times negative 0.4 will 0.4. 10 only has one 0, so therefore I only move the decimal one time. So 10 times 0.4 is just regular 4. Yes, I eliminated the decimal. 10 times 1 is 10. 10 times 1.8, so 10 only has one 0, so I only move it one time. Move it one time, and it will become an 18. So that will become 18w. Look at how simple this problem is. Okay? Draw your barrier, click, box your answer, or box the largest variable term. So this one needs to jump the fence and come over here. So the inverse of a positive 18 is a negative 18w. Negative 18w. Okay. These cancel out. They become 0. Do not put 0w. 20 minus 18 is 2w. Drop this. Drop this. So minus 4 equals 10. We're almost done. This is pretty simple. Circle. Barrier. Who do I get rid of now? Well, the minus 4. What's opposite of a minus? Positive 4. Positive 4. These cancel out. I'm going to move over here. So we have 2w equals 14. God, we're almost done. See how simple these are? divide. The opposite, the inverse of multiplication is division. So I don't know why some of you guys are putting negative. The inverse of a multiplication is not subtraction. Divide by 2, divide by 2. So in this case, W is equal to 7. And that's pretty much it. How to solve multi-step equations with decimals. Now, a lot of you guys are like, well, you never threw a special case. Here, let me give you a special case. I'm going to make this up, okay? Copy it in your notebook. This is a new problem because I did not go over it in class. In this special case, I did not go over it in class. Let's say you get this. Negative 2.5x plus 18.2 equals 18.2 minus 2.5x. Multi-step equation. I have variables on both sides. Let me look at my two variables. Oh shoot, they're identical twins. So I know eventually these will cancel out, these will cancel out. So I'm left with 18.2 is equal to 18.2. Where they're still the same. And I could just say many solutions. And you're done. That's a special case. What happens if I would have changed, I don't know, I'm making this up, this to a 7.4, right? So, identical twin, they cancel out, you have 18.2 equal to 7.4. They're not the same, so that's when you get no solution. Okay? So you could also get these special cases with multi-step equations with decimals as well. Again, pretty much to recap, the most important thing you need to remember is to solve multi-step equations with decimals is you need to learn your place values, multiply by the highest place value all the terms. This one, this one, this one, and this one. Don't forget. A lot of students forget to multiply by the last one, okay? And then at the end, you eliminate all the decimals, and you're able to solve the equation like we normally do. On our next video, we're going to show you how to solve multi-step equations with fractions with like denominators and fractions with unlike denominators. And the process is pretty much the same thing. So that's about it for this video.